I am the red, green, blue, and yellow text reader. We're still in Chapter 8, Energy. In this video, I'm only going to do Section 8.2, which is Power. I'll do 8.3 in a second video. This is a bit of review from yesterday. What is work? When a constant force moves an object in the direction of the force, the work done equals the product of the force and the distance the object is moved. So, work equals force times distance. Power. Power is the new topic for today. Power equals the work done divided by the time it takes to do the work. So there's the definition of power, and then I turn that sentence into an equation. That's next on the screen there. Power equals work done divided by time interval. And so we're going to use power to measure things. And then if we're measuring it, we have to have a unit for it. And so we have another new unit, the watt. 1 watt equals 1 joule per second. Now we could just say joule per second when we're talking about power, but instead they had to take joule per second and name it after somebody because that's what they do in science. And that somebody they named it after was James Watt. He lived in England in the late 1700s. In 1776, a year that is famous in America, he invented a new kind of steam engine. They had already had steam engines for all 60 or 70 years in England. The Industrial Revolution was rolling along just fine. But in 1776, he invented the Watt steam engine. And this, first off, it used a lot less fuel. They didn't have to shovel nearly as much coal into the machine to keep it running. Also, it was much, much more reliable, and it got to be bigger, and it was just better in all kinds of ways. So once the Watt steam engine was invented and was used all around England, that really allowed the Industrial Revolution to take off. And the Watt steam engine came here to America in short order too. And so that's one of the reasons why James Watt is famous. But before we go on, let me talk a little bit more about power. So we did work yesterday. So if I tell you, hey, here's a stack of books sitting here on this counter, there's like 20 books there, and I need you to grab that stack and run them up those stairs over there and move them to the upstairs table. So if that stack of books weighs, I don't know, say 20 kilograms, and you're going to move it up 2 meters up the stairs. So the work done is the force, let's say it's 1,000 newtons, and you're going up 2 meters, so that would be 2,000 joules. It takes 2,000 joules of work to move those books from here to upstairs. That's how much work it requires, 2,000 joules. Now let's say there's 100 stacks of books, and I'm going to ask you to move all those books up those stairs, one stack at a time. Well, if you walk nice and slow and take it easy, it takes you, I don't know, say 30 seconds. So 100 stacks in 30 seconds, that's going to take you almost an hour to get that done. Now, you could, instead of walking up and down the stairs, you could run up and down the stairs. And if you ran up and down the stairs, you could get all that work done in half the time. Here's the first question. Did it take you the same amount of work? Yes. You're moving 100 stacks of books up that flight of stairs. That's the same amount of work whether you do it inside of 2 minutes or 2 days. The difference is power. If you do it in half the time, and let's go back to that, back to that slide. Power is the work done. It takes so much amount of work to move 100 stacks of books. And if you do it in half the time interval, it's the same amount of work with half the time. That means you doubled your power. And that makes sense, right? Because if you're going to run for 20 minutes up and down those stairs carrying a load of books every time you go up, that's a lot of work you're doing in a short amount of time. You have to be really strong. You have to be a powerful person to get that done. Does that help you understand power? I hope so.